Hello and warm welcome to everyone joining us today. I'm your host Dalvinder Kaur from lovely Professional University. We are excited to have you with us and look forward to an engaging and insightful session. So sit back, relax, and let's dive into today's topic, that is application of AI and ML in flood prediction. Before we proceed further, allow me to introduce the experts of the day. Dr. Rajesh Jolly, Assistant Professor, Department of Geography, School of Liberal and Creative Arts, lovely Professional University. Dr. Jolly brings over 8 years of teaching experience and extensive practical exposure from reputed institutions like Punjab Remote Sensing Center and Haryana Forest Department and more. So now I would like to introduce Dr. Shubhrata Haldar. Welcome, Dr. Shubhrata. Department of Geography, Agravan Heritage University, Agra. His research credentials include 20 plus Scopus Web of Science indexed papers and book chapters in reputed journals like Springer and more. Before we proceed further in today's session, I would like to request everyone for any questions. You can write in the chat box or in the Q&A box, and same will be addressed from my side in the end of this webinar. Now I'm going to hand over this session to our experts, Dr. Rajesh Jolly and Dr. Subrata Haldar, and it would be an absolute delight to listen from them. Over to you both.
Thank you, ma'am. Good morning to all of you. On the behalf of Department of Geography, I would like to introduce an online webinar for the application of artificial intelligence and machine learning in disaster management. Particularly, we are going to discuss the disaster, that is the flood management. So on the behalf of the Department of Geography, I would like to invite all of the participants in this online webinar sessions. And in these sessions, we are going to discuss in detail how we are going to introduce different techniques to predict and to manage these type of floods hazards for the public safety point of view. So for start, I'm going to start the session. So we are going to first introduce the Department of Geography. Department of Geography is the department under the School of Liberal and Creative Arts, Social Sciences and Languages. School of Liberal and Creative Arts already have a rank 1 in the Social Sciences subjects worldwide ranking, rank 18th in the Indian global ranking, and it is 43rd ranking in terms of physics and astronomy, social sciences, and in terms of geography, it is going to 32 rank in the worldwide ranking. So this is the ranking of the schools. Then we have the discipline of geography. So geography in nutshell, we can say that it is provide accurate, orderly, and regional descriptions and interpretations of variable character of the Earth's surface. It is like we are going to deal with the different type of characters or features available on the Earth's surface. We are going to interpret it, and how beautifully a geographer can interpret these phenomena, that is going to study in the geography. Next slide, we are going to introduce that what kind of salient features or USP that is going to introduce by the Masters of Science in Geography. So first we are going to start with we specialization baskets that university is going to offer you a lot of core courses in which we are going to have a Department of Geography with core courses like geomorphology, climatology, geography of India, geographical thought. Beside that, department is also going to give the student a basket which you can opt as a specialization stream in your career. Like geography, we are going to offer geospatial technology. We are going to offer a physical geography. We are going to offer a specialization, particularly in the stream of human geography. So these specialized baskets are going to link with your career profile, with your cohorts. It is going to be skill oriented for your career pathways. Beside that, department is also going to provide a industrial week, which we are going to denote it as a summer internship in the area of preparedness. So these streams, they have a innovative pedagogies, like we are going to introduce a case-based assignments. Like in today lecture we have a case-based study of the basin region. Then we have a field-based studies in which students are going to the field to have exposure of the phenomena, to have the challenges and how to deal with these field challenges. And we are going to introduce flipped classroom learning, where we are going to give some homework to the students like case study. Students are going to learn these studies, and we are going to have an interactive session in the classroom where open debate is going on, that how we can handle these different type of problems or different type of case-based studies in that area. So these type of approaches are definitely going to help the students for their learning capabilities, for their critical thinking, for creative knowledge also, because then students are going to be have a better exposure. They are going to have exposure to learn about things and to creatively generalize the problem. They have their own solution, they have their own strategy to tackle these problems. So by these pedagogy techniques, the student innovations are coming up from their minds, and it is going to boost up their ideas. It is going to boost up their knowledge also. So to strengthen their skills, we are having industry tie-up connections. Like in the further slides, we are going to show you that department has already tied up a lot of departments for the prospects of the career point of view for the students. Like we are going to offer the summer internship, we are going to provide the career pathway in which you can choose your career in the further skill enhancements. Like if you want to go the public and private sectors, we have the Indian Meteorological Department where student can use their skills of weather forecasting for prediction of the weather maps. They can produce a weather maps, they can deal with the weather data, and side by side student can do their internship in the field of remote sensing at a specialized remote sensing center, that is Punjab Remote Sensing Center. Similarly, every state has a remote sensing center, so student can choose sometime as their choice of their region for the internship of the program. Like if they want to choose the Haryana, if they want to choose Shimla, so they can choose the state specific remote sensing center for their career prospects also. Side by side, some students have their motives in the environment, they taste in the environmental monitoring. So Environmental Space Research Institute, ISRI, that is a public, private sector, it is also going to provide the internship in that. Then we have the Survey of India, that is a bona fide government agency for the surveying in India. Then we have the National Institute of Disaster Management for control of the disaster. Now these all departments are going to use geospatials in their day-to-day activities. So their day-to-day activities are going to have a lot of training periods for the students, and simultaneously, if the student is going to have training periods, they are going to have their career profiles in these type of streams also. Then last, we have the Indian Institute of Remote Sensing. They are offering a lot of short-term courses, some weekly courses in which students are going to have interacted with that session, and they are going to have certificate in that course. Second, the major salient feature which university is going to provide you, that is a research opportunity. That after the graduation, student is going to achieve the career profile in the research streams like research fellow, junior research fellow, senior research fellow. So when during the MSc geography, they have their dissertations. So in dissertation, they are having a specific research stream in which they can choose any one areas like agriculture, soil, water management, geology, forest resource management, urban and rural planning, natural resource management. So student can choose any one of these research specific area and pursue their career in these. And fourthly, we are going to have a sound infrastructure facilities at the LPU. These facilities are going to be having a smart classroom with all fully AC. We have a cartography and GIS labs. Remote sensing equipments are there like GPS. We have satellite images, latest satellite images which we are going to use in uh, machine learning and artificial intelligence. We have field-based equipments like GPS device, automatic weather stations, in which students have exposure in the field that how they can handle the data, how they can predict the data, how they can use this data for applications and management of the resources. Beside that, we are also going to have some interdisciplinary approach, like student are having a research in interdisciplinary format. Like if the student are going to study some archaeological site, they are going to tie up with the historical studies. So they are going to tie up with the interdisciplinary approach. Side by side, we are going to tie up with the School of Computer Sciences for programming languages, agriculture sciences, application of geospatials. So these type of streams are going to provide the interdisciplinary approach in the stream of geography. So these are the salient features. Scientifically, sometime a question may be rise in the mind of the student that why we are going to choose the MSc Geography at LPU. What new thing that LPU is going to offer in the stream of geography as none other than department is going to offer. So one of the basic that we are going to give you a diversified curriculum to enhance your skills, that with these diversified curriculum, you can enhance your skills in the physical geography, in the geospatial, in the human geography, in the remote sensing, in the environmental studies. This is the plus point when you are going to opt LPU as your career profiles. Then we are having an innovative pedagogy that we are going to have interactive classroom sessions. We are having a case-based studies for live examples of the world, and we are going to have some exposures in the geospatial software, statistical softwares, especially SPSS. We are going to have innovative skill-based course in our curriculum like cartography, remote sensing, GIS, GNSS, SPSS, socioeconomic surveying, geomorphology, because these skill oriented courses are the demand of the era. Now, you are not going with the basic core courses. You have to enhance your skills in the skill oriented courses to grab high packages jobs in your profile. That is why we are going to have in our scheme with the skill based oriented courses. Then we have a diversified industry opportunities for connection and placements. Like we have a public and the private sectors. Public sector, you can go with the government organizations like state promotion center, like IMD, like disaster management institutes. In private sector, you can go with the ISRI, that is a known private company for the GIS software. You can go with the consultant companies like Universal Satellite Mapping Solution companies. So these type of connections and tie up with the department is definitely going to helpful for your enhancing the skill and to build your career in these streams. Then lastly, department is going to offer you a diversified research opportunity stream, because nowadays a lot of research jobs are coming in your careers. These research jobs are some skill oriented also. So you have some application in the research like in the agriculture area, in the watershed management, in the morphometric analysis. So definitely these type of research enhanced skills which you are going to prove with your dissertation will be going to benefit you for your career profile in the research fellow or the senior research fellow, which is also nowadays are high packages jobs. Now, next, I'm going to happy to share that within the few years, we have a very strong placement records from our previous year students with a high package in the geography streams. Like one of our student of the previous year, she is placed in the Vidyashilp Academy as an educator, and she has got a package of 6.6 lakh. It is the student who are getting these type of packages. Then we have the Sarfraz Alam. who has pursued his career in the next geography. Then we have Adit Barua, who is a student of MSc Geography. He is placed in the Municipal Corporation Guwahati and he is working as a GIS analyst. Now see how much package he is getting. He is getting the 5.6 lakh. He is enhancing their GIS skills to management of the resources of the municipal corporations. Then we have some international students who are getting international placements in their country, like Nazifi Umar, in the assistant professors in the Northwest University, Kano. So there are a lot of career profiles by the student. Recently, students are placed in the YS group also. Students are placed in the university satellite mapping consultant in a private company of the GIS. So there are a lot of stories of the career pathway by the students. Now, how the student is going to achieve these career, how they are going to pathway their career in these specific stream. First, they are going to choose summer internship training program in these specific core field. Like some student, you have noticed in the screen that they have opted the IMD. IMD means the Indian Meteorological Department. So they pursue their career in the weather forecasting, to interpret the weather map, to prepare a weather map through geospatial technologies. Some students pursue their career in the State Motion Center. Some students are going to work for cadastral mapping, which is also a new one, with the help of Survey of India department. So during their internship program, they are going to have the skills and knowledge and training to how to achieve these goals in the career. Next, we have some competitions in which, like JRF, we are having a successfully, a lot of students are clear the JRF net. Students are competing and achieving their first winner in the geospatial activities, particularly in the X-Tempo, in the quiz competition also. Some of the world level athlete in the swimming also, they have also been win the trophies. JRF qualified candidates are also very there. And I am happy to share that department has already tie up a one MOU with the State Remote Sensing Center, that is Punjab Remote Sensing Center, for research activity for a program of MSc Geospatial Sciences, and student can now do their training part, internship part in these department with the exposure from the scientist over there. And today we are going to discuss about the application of AI and machine learning in flood prediction with the expert of Dr. Shukrata Haldar. He is assistant professor in the Department of Geography, Agravan Heritage University, Agra. So Dr. Haldar is already expert in the AI and machine learning that is particularly used for disaster, which is very prone in that area, that is a flood management. So during this session, you are going to have knowledge that how we are going to use these geospatial skills, maps, and basic informations for AI learning and machine learning for flood level predictions. So I am going to hand over this session to Dr. Subrata Haldar for giving their expert feedbacks how AI and machine learning will be helpful for management of these disasters, particularly in the flood predictions. So over to you, to sir.
Thank you, Dr. Ajitoli, sir.
Yeah,
First of all, good morning to all the respected teachers, colleagues, scholars, and the students. I am here for the discussion of flood risk management, mapping for the Subarnarekha River Basin in Eastern India, a machine learning approach to fulfill the webinar on the application of AI and machine learning in flood prediction. First of all, what is the relation between the machine learning and the artificial intelligence? Machine learning is a subset of the artificial intelligence, meaning all machine learning is AI, but not all AI is the machine learning. AI is a broad field that encompasses various techniques for creating machines that are perform tasks requiring human intelligence, while machine learning specifically focus on the algorithm that allow machines to learn from data without being explicitly programmed. Sir, please go to the introduction slide. Next slide, sir.
Oh, sure, sir.
In recent years, machine learning has emerged as the powerful tool for the environmental modeling, including flood risk mapping. Machine learning algorithm can efficiently analyze complex multidimensional dataset and identify hidden patterns that influence flood occurrence by learning from the past events and integrating spatial and non-spatial variables such as elevation, slope, rainfall, land use, land cover, and proximity to the river. Machine learning models can predict flood-prone areas with remarkable accuracy. Flood are among the most frequent and devastating natural disasters worldwide, posing serious threats to the human lives, livelihoods, infrastructure, and ecosystem due to the increasing impacts of climate change, unplanned urbanization, deforestation, deforestation and land use changes. Flood events have become more intense and unpredictable, particularly in the vulnerable region. This study explored the application of the machine learning techniques in developing a flood risk susceptibility map using geospatial dataset and selected flood controlling factors. Sir, next slide. Slide. The Subarnarekha River Basin is located in the eastern central plateau region of the. This is the location map of the Subarnarekha River Basin. The Subarnarekha River Basin is located in the eastern central plateau region of India and have selected for this study because of increasing flood frequency and intensity in the recent decades, excavated by the erratic monsoonal rainfall, rapid urban expansion, and deforestation. This basin flows through the state of Jharkhand, West Bengal, and Odisha, and spans an area of approximately 26,000 square kilometers, which accounts for more about 0.82% of the country's total geographical area. The Subarnarekha River is a rain-fed river, but perennial due to presence of the several fault lines within this basin. The river ultimately drains into the Bay of Bengal. The elevation within the basin varies from the considerably from 0 to about 1024 meter approximately from the mean sea level. So go to the objective slide. Next slide, sir. The objective of my study is to delineate and classify the flood risk zone based on the spatial modeling and machine learning techniques. In this objective, I have used several types of. Sir, next slide. This the methodology begins with the selection of flood hazard and vulnerability factors. The key physical parameters such as elevation, hazard, and vulnerability, elevation, slope, aspect, distance from river, drainage density, land use, land cover, and rainfall were used to characterize the hazard potential of the landscape. On the other hand, flood vulnerability factors using the socio-economic indicators like population density, percentage of cropland, and road-river interaction density has been selected. In addition, I incorporated a hydrodynamic model using 2D simulation approach to create a flood inundation map, which added spatial precision to this dataset. All these layers have integrated into geospatial database, forming the basis for the machine learning. This data set was split into two parts. The first one is the 70% for the training and the 30% for the testing for this model. I applied three supervised machine learning algorithms. The first one is the random forest, second logistic regression, and third one is the support vector machine. Each model was evaluated based on the performance accuracy. The final output was the flood risk map categorized areas from the very low to very high flood risk. This map designed not only the scientific output but also as a decision support for policymakers and disaster management authorities, enabling them to the protective measure for the flood mitigation and planning. Next slide, please. The This is the table for the support vector machine, logistic regression, and random forest. Both are these three. Both are supervised learning algorithm can handle binary classification problem. All required labeled training data can be integrated with GIS-based spatial data for mapping. In flood susceptibility mapping, support vector machine is the beneficial due to its ability to handle high-dimensional data and effectively classify complex spatial patterns. Logistic regression is widely used in the flood risk modeling as a benchmark due to its simplicity and interpretability. And random forest is well suited for the flood modeling due to its ability to handle large datasets, rank variable importance, and reduce overfitting. Next slide. Next slide, sir. This is the methodology for the hydrodynamic model. A two-dimensional hydrodynamic model was developed for Subarnarekha Basin using the HECRAS version 6.1 software. In this study, to absence of bathymetry data or field data, so SRTM or data DEM was utilized to define the riverbed topography. This point, sir, have you changed the slides, sir? There is not showing actually.
Next slide.
No, go to the methodology part of hydrodynamic models.
This one.
Okay. A two-dimensional hydrodynamic model was developed for the Subarnarekha Basin using HECRAS version 6.1 version of software. This in the study, to the absence of the bathymetry data, SRTM demo was utilized to define the riverbed topography. This point, the first one rate point is the Jamshedpur city. In 5th August 1997, this point recorded 6,254 cubic centimeter per second water. And Ghatshila, the second one point is the Ghatshila recorded 10,583 cubic meter per second, the amount of water. A hydrodynamic model was developed based on the water amount for the Jamshedpur city, and Manning roughness coefficient was adjusted until the simulated flood depth closely matched the observed data levels at the Ghatshila gauging station. The resulted flood inundation map was subsequently used as an input layer in the support vector machine, random forest, and logistic regression model of machine learning algorithm for the flood susceptibility analysis. Next slide, sir. Sir, have you changed the slide?
Yeah, I have changed the slides. It is drainage
Sir,
density and rainfall.
go to the slide. Elevation, slope, and sir aspect.
Yeah, this one.
Just after the hydrodynamic model.
Yeah, I have changed the slide. That is
Okay.
elevation, slope, and aspect.
In this slide, this is the variables I have used in the for the predicting of the flood risks. In this slide, the elevation, in this slide, the elevation, slope, and aspect have presented. Elevation is a fundamental topographic parameter in flood modeling, as it directly influences the flow and accumulation of water across the landscape. Low-lying areas are naturally more susceptible to water accumulation and prolonged inundation. especially during high intensity rainfall or river overflow events. In contrast, higher elevation zones typically remain unaffected. On elevation data is crucial for the delineating floodplain, modeling water depth, and simulating flood spread in both hydrodynamic and machine learning based model. The next one is the slope. The slope determines the speed and direction of the surface runoff. That's why the slope has been selected as a variable. Steep slopes facilitate faster water movement, reducing the likelihood of the flooding but increasing erosional potential. Conversely, gentle or flat slopes slow down runoff, promoting water stagnation and infiltration, which significantly increases flood susceptibility. Slope is a crucial factor in both terrain analysis and hydrological modeling for identifying the vulnerable zone. The next one is the aspect. Aspect refers to the direction of slope faces which influence solar radiation, vegetation cover, soil moisture retention, and evapotranspiration rates. Although aspect has the less directional role in flood risks compared to the elevation and slope, it becomes relevant in the combination with other variables like land cover and rainfall. For example, north-facing slope in the northern hemisphere may retain more moisture due to lower sunlight exposure, increasing increasing saturation and runoff and potential during the storm. Next slide. The proximity to the river channel is one of the important determinants of flood susceptibility. Area closer to the rivers are more prone to flooding, especially during peak discharge. Even peak discharge seasons. When the river overflows its bank, as the distance from the river increases, the risks of the generally decrease due to the reduced influence of the direct inundation. Drainage density is defined as the total length of the stream and rivers per unit area of the watershed. It reflects the efficiency of surface water drainage and the proximity for the landscape direction. High drainage density areas can either increase the flood risk due to the rapid convergence or flow or reduce localized flooding. Thus, its influence that depends on the terrain, land cover, and rainfall characteristics. But generally, higher drainage density in low-lying or impervious areas leads to higher flood risks. Rainfall. Next one is that rainfall is one of the most direct and critical drivers for flood events. High intensity or long duration rainfall leads to surface runoff, rising river levels, and ultimately flooding. When rainfall exceeds the infiltration and storage capacity of land, water begins to accumulate, especially in poorly drained and low-lying area. Next. This is the land use land cover map. This is the land use land cover map of the Subarnarekha River Basin. Why the land use land cover have selected in this study? Because land use land cover plays a important role in determining the surface runoff behavior, infiltration capacity, water retention ability of all area, and which directly influence the flood risks. Different land cover types respond differently to rainfall and water movement, thereby affecting the magnitude and extent of flooding. Urban areas with first of all the built up area with the paved surface that like the roads buildings reduce infiltration and increase surface runoff, leading to higher risks of floods, especially in poorly drained locations. And agricultural land may offer the moderate infiltration capacity, but during the peak rainfall or if saturated, it contributed to surface runoff. Dense vegetation or vegetation cover or tree cover increases infiltration and evapotranspiration, reducing runoff and mitigation flood intensity. Water body naturally store flood water and act as a buffer during the heavy rainfall events. The LULC map has been prepared through the maximum likelihood algorithm, and the accuracy measured by the kappa coefficient, which is one of the most reliable accuracy assessment. This result found more than 80%. The kappa result provide the more than 80%. That is the excellent agreement. Next slide, please. In terms of in terms of vulnerability factors, densely populated areas, especially along the river banks, low-lying zones, face greater risks in terms of casualties, property losses, and economic disruption during flood events. So, where high population density has the higher flood vulnerability. Cropland and next the cropland percentage of cropland in low-lying floodplains are especially vulnerable to the inundation, leading to crop damage and yield losses, soil erosion and nutrient depletion, livelihood disruption, especially in the agrarian economies. The next map is showing the interaction between the road and river. The interaction between the road and river represent the physical connectivity and potential obstruction along river corridors. Road that cross or run parallel to river, roads that cross or run parallel to river, that alter natural drainage and obstruct water flow, act as a barrier, and also act as a barrier, causing backwater effects or localized flooding. Next slide. This is the simulated flood depth map. This is the simulated flood depth and velocity of the middle to the middle to lower part of the Subarnarekha river basin. The maximum water depth found more than 39 meters, and maximum velocity have found more than 1.03 meter per second. Based on the flooded and non-flooded area, the third map have been generated and based on the flooded and non-flooded area for training and testing purpose. The total number of 1200 have been selected for the flood and non-flooded area for the machine learning to run the machine learning algorithm. Next slide, please. This is these are the result of the flood risk assessment through the support vector machine, logistic regression, and random forest respectively. These two tables, two table in the below indicates the result of training and overall data, where AUC, that is the area under curve, measure the ability of the model to distinguish between the classes. That the value closer to 1 indicates the better performance, and the next one, CA, is the classification accuracy, proportion of correctly classified sample. F1 is the F1 score, harmonic mean, or the precision and recall. Balance, both are imbalanced data. Precision is the proportion of true positive among predictive positives, and recall is the proportion of true positive among actual positive. The model comparison of the training data. The first table indicates in case of the support vector machine, AOC indicates 0.825, that is decent discriminative power. CA is 0.767, moderate accuracy. F1 is the 0.795, balanced precision and recall value 0.85 and 76 respectively. That's indicate the good at avoiding false positive and slightly lower sensitivity. This SBM model indicates decent model but not the strongest among the three. The random forest, in case of random forest, AOC is the 0.999, nearly perfect model. C is the 0.986, extremely high accuracy. Best performing model, this is the best performing model across all metrics, slightly overfitting slightly, but still excellent. And next, the slightly logistic regression, AOC 0.911, very good discriminating ability, and C is the 0.887 high accuracy, that's indicate the high accuracy. Good model, interpretable, and might be preferable if simplicity is needed. In case of the next table, in case of the overall data, support vector machine, AOC indicate the 0.793, that is moderate class separating ability. C is 0.74, lower accuracy. F1 is 0.776, acceptable balance. Precision is the 0.85, that's indicate the fewer false positive. Recall 0.74, misses more true positive. This is the least performing model. This all value indicates the least performing models. And the next, the random forest, AOC is the 0.922, excellent discriminative power. CA indicates 0.90, very high accuracy. F1 is 0.90, strong balance. This is the best performer again. as like the previous table, previous training model. This is the again, and the strong consistent result across all metrics. The logistic regression AUC 0.899, it is indicate the very good. CA is the 0.8833, this indicate the high accuracy. This is the solid performance and simpler to interpret. A good choice when the model transparency is important. Overall, it can be said that the best performing model is random forest, reliable and interpretable is logistic regression. Weaker performance model found as the SVM or support vector machine. Next slide, please. This is the confusion matrix of the support vector machine model and support vector machine model, random forest and logistic regression. In case of the confusion matrix of the support vector machine model, correctly classified 591 observation out of 802 actual class 0, that is non-flooded occurrence, indicating it performed well in identifying the negative classes. However, it also misclassified to 211 of this as class 1, resulting in a high number of false positives. On the other hand, the model accurately identified 110 out of 142 actual class 1, that is flood event occurrence, demonstrating good recall for positive class, although it missed 32 cases, leading to some false negatives. Overall, the model tends to detect the most positive cases effectively, but struggles with the precision due to a significant number of incorrect positive prediction. The confusion matrix, the next table, the confusion matrix of the logistic regression correctly predicted 768 out of 802 actual class of non-flooded classes, showing high accuracy in identifying the negative class. Only 34 occurrence of class 0, that is 0, which is the non-flooded, which is indicate the non-flooded occurrence, were incorrectly classified as the class 1, that is the flood observation 1, indicating a low false positive rate. For class 1, the model accurately predicted 66 out of 142 observation, but it misclassified 76 of them of class 0, leading to moderate number of false negative. This indicates that while the model is highly precise, effective in the minimizing false alarm, it struggles to capture all the positive as reflected in the relatively lower recall. In the last last table, this is the last table of the confusion matrix. The random forest model accurately classified 777 out of 802 actual classes of non-flood observation, demonstrating excellent accuracy in identifying the negative class. Only 25 points classes and 0 cases were misclassified as a class 1, indicating a low false positive rate. For positive class, the model accurately predicted 77 out of 142 occurrence, though it misclassified 65 positive cases as negative, resulting in moderate number of false negative. This suggested that while the model performs very well in avoiding the incorrect alerts. Next slide. These are my findings. These are all my findings of my study. The major findings of the study are that among the machine learning models applied in the study, the random forest found as the random forest algorithm demonstrated as the highest predictive performance and was identified as the most suitable method for the flood risk prediction in the Subarnarekha River basin. And the lower table indicates the flood area of flood risk. This is the flood risk area with the actual and the percentage value. In case of flood risk area, low risk category covers the largest portion, accounting for 21.89 of the total area, followed closely by the moderate risks and high risks. The moderate risk area covers the 20.18% and high risk area covers the 19.53% respectively. The very low risk area makes up 19.28%, while the very high risk category represent 19.08%. The smallest but still a significant portion. This suggested that the flood risk is relatively evenly spread with nearly equal areas falling into low, moderate, high, and very high risk zone. Next slide. This is the flood land use land cover distribution across different flood risk classes reveals insightful spatial pattern. Cropland is dominant land cover in all the classes, ranging from 6.05% in very low risk zones to over 10% in the low, moderate, very high, and very high risk zone, respectively, highlighting the widespread exposure to the flood hazard. Paloland shows a decreasing trend from the 9.32% in very low to 3.19 in very high risk, suggesting that less productive and uncultivated land trends to occur in safer areas. Vegetation cover remains relatively stable, varying between the 2.99% and 3.36 across all risk zones, while built-up area shows a gradual increase from 0.5% in very low to 1.22% in moderate and 1.12% in very high risk zone, indicating that urban settlement are expanding into more flood-prone areas. Notably, wetlands are strongly concentrated in the very high risk zone, that is 1.55%, underscoring their vulnerability and their potential role as a natural buffer in flood-prone environment. And lastly, this topic with relevance in terms of address sustainable development goal, especially sustainable development goal of 11 and 13, supports local flood management planning and early warning system, can inform disaster risk reduction strategies and climate resilience planning. Thank you. Thank you, sir.
Thank you, sir. It's a wonderful session. Thank you.
Thank you so much, Dr. Rajesh Jolly and Dr. Shubhrata. Can we take questions, Dr. Rajesh and Dr. Shubhrata?
Sure. Sir, one of the question maybe rises as from a student point of view, that how we are going to choose these layers. What are the criteria behind how to choose the spatial layers? My voice
Sir,
is
can
audible,
you
sir?
repeat? Can you repeat again, sir?
My question is that you have chosen a lot of layers for the flood prediction model. Like
Yes, sir.
how we can choose these layers?
First of all, I have used different types of variables. From the like elevation, slope, aspect. These are collected from the SRTM DEM. This is freely available in the website or USGS Earth Explorer website. The next one, the average rainfall that can be collected from the Google Earth Engine. This data provide more than 50 years average data. And next, I have also choose the percentage of land use land cover. I have prepared the land use land cover using the maximum likelihood algorithm, and by the using the ArcGIS software. And this data is prepared from the Landsat 8, that is the Waylight TIRS. And after that, this layer have been generated, and from this land use land cover, the percentage of the cropland area, the village wise layer have been created, the percentage of the cropland area, and the road and the another layer was created from the road and interaction between the road and river. That is the road layer have been collected from the open series map that is freely available. And the another one is the river that is generated from the SRTM. This interaction point have been created, this layer have been created by the geospatial tool in the ArcGIS just geoprocessing tool intersection in the ArcGIS environment. And next, the hydrodynamic model have been created in the HECRAS software. First of all, the to created the hydrodynamic model, I have to know the anyone have to know the basic two more than one value, flooded value. That is, in this study, I have used the Jamshedpur and Jamshedpur station and the Ghatsila station, but uh, that value is the 1997. At the time of 1997, that there was a two data was recorded. These two data have been collected. The first one was more than 6,000 cubic centimeter per second, and second one was the 10,000 more than 10,000 cubic meter per second. The first one the first one in the HECRAS software, for the hydrodynamic model, the flooded layer have been created by the using hydrodynamic model. The first one is the Jamshedpur city have been used the value 6,000, which was the flooded occurred in the 15 August 1997, and this the lower part of Harshila have been has been used as the verified as for the use for the accuracy assessment. For the accuracy, the 6,000 more than 6,000 cubic centimeter water have been continuously calibrated in this model until I have get the exact value or nearby value at the Ghatsila 10,000. Uh, like this model, this have been created.
Sir,
And
next
yes,
question
sir.
that is come in the mind of the student that you have chosen the artificial intelligence and machine learning. If student want to pursue their career in these streams, what kind of courses, what kind of skills they required?
First of sir, that is first of all career aspect in the machine learning from the field of geography. First position like the position remote sensing GIS and remote sensing and GIS analysis and specialist. In this for this position, the student all have to know the Python, Google Earth Engine, ArcGIS, QGIS, environment, ENVI like this software, and machine learning skill needed the image classification like the random forest supervised support vector machine, CNN, etc. And then next one, the environment data scientist. The tools need Python, R, TensorFlow, SQL. The machine in this category, in this field, the machine learning skill needed the regression analysis, time series regression forecasting, neural networks. The third one, urban planner with the machine learning expertise. For this for this post, the student have to know the predictive modeling, land use simulation, optimization algorithm, and tools have to know the ArcGIS, Google Earth Engine, Python, Net, Logo. And the next like the geospatial AI, artificial intelligence, and machine learning engineer from the field of geography. And in this category, the student have to know the machine and know the deep learning like the CNN for the image analysis, geospatial database, cloud computing, cloud computing like the AWS and Google Earth Engine. And the next, the climate and disaster risk analysis, the analysis machine learning skills in this. For this post, the machine learning skill needed multivariate classification, spatial clustering, probabilistic modeling, etc. And others post like the geodata consultant, spatial data scientist. In this position, this position are available in the such as insurance from the different kinds of insurance company, real estate business, public health, and logistic business. And and after all, sir, lastly, for the academic and research career can be generated, can be developed by the uh, GIS, machine learning and artificial intelligence. That is, the student can be pursue PhD postdoc on geo AI, environmental modeling, urban system, hydrological machine learning application, hydrodynamics, flood risk, future different kinds of future uh, disaster prediction. It's it, that's like Yes, sir.
So very true said that now the present era is the era of the application of geospatial. So now most of the government organization or even public or private sectors, they are having a application tools, and artificial intelligence and machine learning is a key role to getting these jobs. So,
Yes, sir.
do you think that higher package jobs, like either it is coming in the cadastral mapping, either it is coming in the municipal corporation, either it is coming in the hydrological modeling. So, do you think now geography student can boost up their career with the use of AI and machine learning?
Yes, sir. Definitely, the GIS from the field of the geography, all the student can be, all the student uh, can be enhance their career and the high packages jobs like in machine learning and the AI, artificial intelligence. There are different kind of courses are available. You can you can suggest to them, sir. You can also run into your university.
Sir, last question. Like if a student is very new toward the geospatial stream, how they can build their career in the advanced, that is artificial intelligence and machine learning by using the geospatial technology? How they can pursue their career?
Sir, first of all, in machine learning, first of all, no one student can direct jump into the machine learning and the artificial intelligence without knowing the GIS and remote sensing. First of all, the student uh, have to know the GIS remote sensing technique. First, like the land cover classification, hazard susceptibility mapping. What is hazard susceptibility mapping? Urban growth prediction, environment monitoring, climate impact modeling, socioeconomic health geography, and they and after that the this is basically this machine learning and GIS remote machine learning and AI is the totally code based application. Some of some of software provide not need to the coded, but maximum software and for the best result of any model of any prediction, the coded is needed. So first of all, all the students have to know the GIS and remote sensing very well. Then I I'll suggest them to go to the machine learning and AI applications.
Very true, sir. Because nowadays, if students want to pursue their career, they have a sound knowledge of the core courses, like whatever the core courses, geomorphology, climatology, environmental studies. Side by side, they have enhanced their skills in these type of skill-oriented courses, like geospatial management, programming languages, to pursue their
Yes,
careers
sir.
at a high package job salaries. I think,
Yes, sir.
sir, we have concluded the session.
Thank you so
Actually,
much,
sir,
Dr. Shah. Yes.
actually, sir, from the field of geography, a student have to know first the GIS and remote sensing. After that, the student have can go the machine learning and AI, sir.
Yeah, very said. Very true said, sir.
Thank you so much,
Yes, ma'am.
Dr. Rajesh Jolly and Dr. Subrata Haldar. If anyone
Thank you, sir.
have any questions regarding the admissions, they just write on us at admissions@lpu.co.in. You can do WhatsApp chat with us. Our WhatsApp number is 985256900. I'm repeating the number. It's 985256900. As we come to the end of this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information for better decision making regarding admissions. If anyone wants to access this webinar again, they can visit our website, that is lpu.in, or can be accessed on YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a great day.
Thank you.
Thank you.